Scientific notation is an application of rational numbers, since when dividing we can express very large or very small numbers. The scientific notation is written as the product of two factors. First, a number greater than or equal to 1 and a power of 10. Well, this number is also greater than or equal to 1 and less than 10. So it can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. The power of 10 can be positive for large numbers or negative for small numbers. So here we have some examples. We have the standard form of a number, and then we have the scientific notation. So here, for example, the distance between the Earth and Mars is 384,000 kilometers. So we want to express this number in scientific notation. So as you can see, the number between 1 and 10 is 3.84, and since this is a large number, so the power of 10 is positive. But how many times? It depends on the places you have to move these decimal points. So here we can see 1, 2, 3, 4, and 5. Since this is a large number, the power of 10 is positive 5. So this number is 3.84 times 10 to the 5th power of 10 in kilometers. So you can see this is a short way to express this large number. Now let's take a look at this one. This one has the inverse process. So the distance between Sun and Mars, the Sun and Mars, is 2.3 times 10 to the 8th power in kilometers. So here we have 2 and 3, which are the two digits here, and the power is 8. So here we start counting 1, 2, 3, 4, 5, 6, 7, and 8. This is in kilometers, and these spaces will be completed by using zeros. And then we write the number using the commas to separate thousands, millions, billions, etc. So you can see that the distance between Sun and Mars is 230 million kilometers. Here we can also use scientific notation to express very small numbers. So in this case we have the size of an object. When you look at this object into the microscope, for example, so here we have that I know this number is very small. So we take the same digits, 532, but the number to be chosen is 5.32, because remember the first factor is a number between 1 and less than 10. So here, now to know the power, I know it's negative. Why? Because this number is very small. So we know that power of 10 by counting places. 1, 2, 3, 4, 5, and that's it. So negative 5. And the units again are in meters. And finally here we have the situation to do the inverse process. We have the mass of a very tiny object, which is 2.48 times 10 to the negative 5th power of kilograms. So here we have the 3 digits. This time, since we're moving the decimal point to the left, we write the same digits and we start counting 5 places to the left, since we know this number is very small. So here, 1, 2, 3, 4, and 5. The decimal point would be here, and then we complete the remaining spaces with zeros, and we will get the same units, kilograms, and this number is equivalent to this number, but this is a shorter way to express the number in scientific notation.